Okay, in this podcast we're going to take a look at what happens during a net or during a precipitation reaction. So here I have silver nitrate and sodium chloride. So let's think about what's going to happen if I put them both in water. So I have two solutions. The silver and the nitrate are dissolved in the water, and so is sodium chloride. So imagine I have two different test tubes. They both have aqueous solutions of different ionic compounds. Okay. So, or I could just take solid silver nitrate and solid sodium chloride. I add them to the water, and when they go in, the silver and the nitrate separate into their ions, and so does the sodium and the chloride. Okay. And they move around until the silver and the chlorine come together, and you see them form a material that starts to cloud and then settle at the bottom of the container. This is a solid. It's called silver chloride, and we know this as a precipitate. Okay. The sodium and the nitrate do not come together. They stay there as ions. So imagine I have a whole bunch of them, right? As the silver and the chlorides come together, the pile of my precipitate grows and grows until all I have left is the sodium and the nitrate. And they are not going to combine. They like to be dissolved when they're in water. I have this pile of silver chloride at the bottom of my container. Okay, so if we look at what's happening here, we have the silver nitrate and sodium chloride, and before they actually react, the silver and the nitrate are dissolved, so they're separate in the water. Sodium and the chloride also dissolve, okay? And when they react, when the silver and the chloride come together, it forms a solid. They are no longer there as ions. And I also still have sodium and nitrate ions. So I would call this, what I have written right here, the total ionic equation. Okay, so let's do this again. Put sodium nitrate and sodium chloride in the beaker. The silver and the chloride come together, form a insoluble compound that forms a solid. And because I have formed something new, this is a new solid material, I have a reaction. If the silver and the chloride didn't react, just like the sodium and the nitrate didn't react, I would have no reaction. Because I would have started with a bunch of ions and ended with the same ions. Nothing changed. Okay, so in order for a reaction to occur, I have to create a new product. Alright, so my sodium and my nitrate, which are just floating around, there's no reaction between them. Nothing's happening. Okay? Nothing happens when they come together. They want to stay dissolved. Okay? And because they don't participate in the reaction, we call them spectator ions. Just like you would, if you're at the sidelines watching a game, you're a spectator, you're not involved in the game. Okay. So silver and the chloride do react, though, and form this solid. So the net ionic equation, which we're going to write next, is constructed from the ionic equation. Here's the complete ionic equation. Everything is ions to start. Silver chloride forms the solid. The nitrate and the sodium ions are still floating around. Okay, so the silver and the chloride come together to form silver chloride. But if you notice, the nitrate on the left is the same thing as the nitrate on the right, so I can simplify and remove them, right? They're both on the same side, just like I would in math, right? The sodium on the left is the same thing as the sodium on the right, so I can also eliminate that. Those are called my spectators. I'm going to cross out my nitrates and cross out my sodiums because they are not involved in the reaction. Okay, they're not participating in the reaction, they're just spectators. We eliminate them. So what that leaves is the silver ion plus the chloride ion, and I put that in my net ionic equation, and they are reacting to form silver chloride. The end. That's going to do it.